All right, 37. We're on the extended response here. It says the bill for a car repair, parts and labor, was $458. The cost of the parts was $339. The cost of the labor was $34 per hour, which is not unreasonable for a mechanic. It's actually probably a pretty good price. Write and solve an equation to find the number of hours of labor. That question is not worded well. But here's how I would do it. So you've got basically, when you go to the mechanic, and this is true in real life, you've got parts and labor. So your total cost is composed of the literal, like, physical pieces of car that you need, plus the time and experience and expertise that you're paying for that person has, right? The whole point of taking your car to the mechanic is you probably don't know how to fix it, so you have to actually pay somebody who has learned everything how to fix it. So the cost we're going to put as Y. What we're going to do is we're going to figure out, okay, how are we going to write parts and labor? The parts are a one-time cost of $339. It's not like they have to do that every hour that they're working on the car, charge you $339. No, it's like if you need a muffler, it's $339, right? The cost of labor, however, changes because it depends on how long the person works. So the labor is going to have a variable with it. And what I'm going to do is I'm going to make X the number of hours. So X is going to be the number of hours of labor. Okay? Number of hours of labor. And the question is, how much is the labor going to cost? And so what if they only worked for 1 hour? So it'd be 34 times 1. What if they worked for 2 hours? It'd be 34 times 2. What if they worked for 2.7 hours? You would do 34 times 2.7. What if they worked for X hours? You would do 34 times X, right? So that's what we're going to do. We're going to write in 34X here. Okay? And then what we're going to do is we're just going to solve this for X. And we shouldn't actually put a Y in here. Sorry, that's kind of silly. Instead of Y, we actually know what the cost was. We know the cost was $458. So we're just going to solve this for X. So to do that, I would subtract 339 from both sides. So subtract 339. And when you do that, hold on, I need a calculator, sorry. That would be 100, let's see, 458 minus 339, that would be 119. So 119 is equal to 34X. I'm going to come up here and finish this problem. So 119 is equal to 34X. And to solve for X here, I would just divide by 34. Divide by 34. So X is whatever 119 over 34 is. 119 over 34. 3.5. Okay, so we're going to say the hours of labor would be 3.5 hours. And, oh, look at me, I should have written the equation up here. 458 is equal to 339 plus 34X. All right, how about 38? Graph the equation 2x plus 3y equals 12. So you can do this all sorts of different ways. Most of you guys seem to like slope-intercept form. Some people will find the x and the y-intercepts. You can do that. Let's do slope-intercept form. So I'm going to subtract 2x from both sides. The goal here is to get the y by itself. So that's 0. So you have 3y is equal to negative 2x plus 12. And then we're going to divide by 3, divide by 3, divide by 3. And then y is equal to negative 2/3 x plus 4. So I'm just going to come over and drop a point at 4. And then we're going to go down to right 3. So down to right 3. I guess I can only get one point on there. So we'll draw the line there, and that's it. All right, 39. A climber is on a hike. After 2 hours, he is at an altitude of 400 feet. After 6 hours, he is at an altitude of 700 feet. What is the average rate of change? So average rate of change is really just another way of saying speed or how quickly you're moving. So what you want to do here is you want to say, okay, look, so at 2 hours, we were at 400 feet, and at 6 hours, we were at 700 feet. And the question is, how quickly are we moving? So in order to talk about how quickly you're moving, you have to give a distance that you've covered, and you have to divide that by some amount of time that you've spent covering that distance. That's how you give your speed, right? Usually we think of speed as miles per hour. So miles divided by hours. In this case, we're going to do feet per hour. So how much distance do we cover here? Well, if you just do 700 and take away 400, that would give you 300 feet. So that's how much distance was covered. How much time did it take to cover that distance? So it's going to be the difference between 6 hours and 2 hours, right? So it was 4 hours was spent covering that distance. So 300 feet over 4 hours would be 75 feet per 1 hour, right? 75 feet per hour. That is the average rate of change. It's not saying that he did 75 feet in the first hour and then 75 feet in the second hour. Maybe he did 100 in the first hour and 20 in the second hour. But the idea here is that on average, over those 4 hours, it was 75 feet per hour. And that's it. That's your answer for that one. All right, number 40, solve the following system by a method of your choice. So you can solve this however you want. I will say this, if you ended up graphing this, then what happens here is you get a couple parallel lines. And so remember, the solution, if you're graphing, is all the place where the two lines cross. And if they never cross, then you would have no solutions. So if you graphed it, that's what would happen there. Personally, if I see this, I'm going to just do a substitution real quick, just because I see, like right here, you already have y equals 4x minus 8. So what I'm going to do is I'm going to take this equation here, negative 4x plus y is equal to 2, and I'm just going to substitute in, instead of the y, I'm going to substitute in 4x minus 8 in red here. This is equal to 2. So, and then we're just going to solve. So if you have 4x minus 4x, that's 0x. So those go away. And then you get negative 8 is equal to 2. And when you get something like this, the question is, what values of x would make negative 8 actually equal to 2? And that's dumb. That can't happen, right? Now, look, if we had x minus 8 was equal to 2, you could ask, like, hey, what values of x would make x minus 8 equal to 2? And you could figure it out, right? It'd be like, what, 10? The problem here is that negative 8 can never equal 2. So when you get something like this, this is where you have no solutions. There are no values for x and y that you could plug in that would make both of these work at the same time. All right, next problem, 41. You went shopping this weekend. You bought your friend Joe 2 shirts and 3 sweaters for $93.40, and you bought your sister Jenny 4 shirts and 1 sweater for $74.30. How much did each shirt and sweater cost separately? So we don't know how much the shirt and sweater cost. Personally, I'm just going to make x the cost of 1 shirt, and I'm going to make y the cost of 1 sweater. And then what I'm going to do is I'm going to set up a couple equations that use that information. So let's look up here. It says Joe, so we bought Joe 2 shirts and 3 sweaters, and it was $93.40. So 2 shirts and 3 sweaters was $93.40. So in the red here, what I'm going to do is, okay, 1 shirt is X. So if I have 2 of them, then that would be 2X. That's how much money I spent on the shirts for Joe. How much money did I spend on the sweaters for Joe? Well, if 1 sweater is Y, then 3 sweaters would be 3Y. And then altogether, I spent $93.40 on Joe. Jenny was 4 shirts and 1 sweater. So 4 shirts would be 4X, 1 sweater would be 1Y, and all together that was $74.30. Okay, so now we just need to, we have a system of equations here. We have one equation, another equation. We have a system of equations. Now we just need to solve for x and y. It's up to you how you do this. You can graph, you can do substitution, you can do elimination. Personally, I would probably just do elimination here. I'm going to actually, this might seem a little weird to some of you guys. I'm going to multiply the top equation by -2 because I would like to eliminate the x's. Most of you would probably eliminate the y's, but I'm going to eliminate the x's here. So when I do that, here's what I get. I get -4x, so the x's will cancel there. Then I get -6y is equal to, oh, that needs to be negative. Remember, multiply by -2. Multiply everything by -2. -2, -2. $186.80 is what I would get there. Okay? So the x's are going to, when we add these equations together now, the x's, that'll become 0. This is -5y, so y minus 6y is -5y, and then this is, oh boy, I need a calculator for this. 7430 minus 186.80. So that's going to be -112.50. So you have 5, so you have -5y is equal to -112.50. If you divide by -5 on both sides, you would get that y is equal to, divided by -5, 22.50. So, all right, so what is that saying? A sweater is $22.50. Well, now we just need to figure out how much a shirt would cost. So let's take our original equation, 2x plus 3y is equal to 93.40. And what we're going to do is we now know that y is 22.50. So we're going to do 2x plus 3 times y, where y is 22.50. And that's equal to 93.40. And then we're just going to solve for x here. All right, so 2x plus, all right, 3 times 22.50 is 67.50. And that's equal to 93.40. I would subtract 67.50 from both sides. And then what do we get here? We get 2x is equal to, so 93.40 minus 67.50 would be 25.90. And then if you divide both of these by 2, you would get, running out of room here, you would get x is equal to $12.95. Okay, so that's your solution for that. All right, so that means a shirt then. So a shirt is $12.95. All right, let's look at 42. They want you to solve the equation, so I'm just going to rewrite it here. 10 is equal to -2/3 times 5p minus 16. And what I recommend on something like this is that you multiply both sides by 3. And the whole goal of that is that takes care of this 3 right here. So what's going to happen is you're going to have 3 divided by 3, which is just 1. And so that's going to get rid of that. So you're going to have, when you do that, on the left you'll have 30, because 3 times 10 is 30. And then you'll have -2 times 5p minus 16. And then we can just solve from here. If it was me, I would distribute the -2. So you get 30 is equal to -10p plus 32. And then I would subtract 32 on both sides, because the goal is to solve for p here. When you do that, I'm out of room here, so I'm going to come up here. You get -2 on the left, so 30 minus 32 is -2. And then on the right, you get, let's see, -10p. So then if we're solving for p, you would divide by -10. Make sure you divide here, because it's -10 times p. So to undo the multiplication. You have to divide. All right, so P is negative 2 over negative 10, which just reduces to 1/5. So P is 1/5. All right, consider the following sequence. The first term is 4, and the common difference is 5. So write the first 6 terms of the sequence. Well, that's pretty easy. So the first term is obviously 4. Next term would be 5 more than that, so 9, and then we're just going to keep adding 5 every time. So 19, 24, 29. That's the first 6 terms of the sequence. Next question is to determine the 412th term of the sequence. So this is kind of annoying, right? Theoretically, we could add, 5 like hundreds of times, but really, if you just kind of pause and think about this for a minute, you're going to have a ton of terms in between the first term and the 412th term, right? And so the question is, what's the 412th term? We covered like methods for figuring this out. Probably the easiest way to do this is to think through like, okay, if the first term is 4 and you want to get to the 412th term, you're going to have to jump 411 times, right? If you jump once, it gets you to the second term, right? So a sub 2 would be right here. That would be the second term, right? That's one jump of 5, right? So that gets you 9 there. So the question is, how much are we going to have to add to 4 to be able to get to this term? Well, if we jump 411 times and each jump we're going up by 5, then what I would do is I would do 411 times 5, and I would add that amount to 4. So 411 times 5 is 2,055. What I would do is I would say, all right, look, I'm at 4. And if I jump 411 times, that means I'm going to add 2,055 to 4. So all I'm going to do is take 4 plus 2,055, and that would give me 2,059 would be the 412th term. So that's a pretty nice, quick way of checking that. Then we get a really difficult question. So what if we wanted to know the nth term of the sequence? So like I just asked you for the 412th term, right? And we came up with a pretty quick answer, right? We said, okay, well, we're at 4. We'd have to add 5. We'd have to do that 411 times. So the question is, how could we figure out if I just gave you n, like tell me what I would have to do to the number n to figure it out. And there are a couple ways you can think about this. The first way is look at what we did, right? So we had our answer for the 412th term, right, was we took 4, which is what we started at. That was a sub 1. And we added 411 times 5. So 5 was the common difference. And then what is 411? Obviously it's 411, but like why is 411 special in this scenario? 411 actually happened to be 412 minus 1. It was just 1 less than 412. So for example, if I wanted the 568th term, what would I do? I would start at the first term, a sub 1, and then I would add a certain number of times 5, right? So the number that I would jump here is 567 times, right? Because if you're at a sub 1, which is 4, and you want to get to a sub 568, that would be how many jumps? That would be 567 jumps. And so what we notice in general is that the number of times that you have to jump is just 1 less than this number, right? So this is 568. If you start at 1 and you get to 568, that means you jumped 567 times. So here's the question. If I was on the nth term, what would I need to do? I would need to take 4, which is the first term, and I would need to add 1 less than n times 5, right? That's it. That's your answer. So basically your answer is, so it's 4 plus n minus 1 times 5. If you would like, you can distribute the 5 here. So what is that? 4 plus 5n minus 5, right? 5 times n is 5. 5 times negative 1 is minus 5. Let's simplify this. So this would be 5n, and then if you have negative 5 plus 4, that would be minus 1. So 5n minus 1 would tell you instantly if I gave you the nth term, that term would be just 5 times n minus 1. Okay. The other way you can do this is you could set up like a table of x and y values. And the x is the number term that you're on. So like the first term was 4, the second term was 9, the third term was 14, the fourth term was 19, so on and so forth. The 412th term was 2059. And what you'll notice here is that in order to get from the x value to the y value, what are we doing? We are multiplying by 5, and then we are subtracting 1. So if instead of the 412th term, I wanted the nth term, you would take 5 times, you'd multiply by 5 and subtract 1. It's the exact same thing that we got up here. It's just a different way of thinking about it. All right, last problem here, number 44. We're going to draw a line of best fit for the data. So let's do that. I'm going to just kind of eyeball this. So let me see if I can actually draw a nice straight line here. All right, so we got our line of best fit on there. And the first question here after that is, what is the slope of your line of best fit? So what I'd recommend doing is grabbing a couple points that are on your line and then using those to figure out your slope. So I'm just going to grab, let's see, I'm trying to look for a place where it crosses nicely. So like right there, it goes through pretty nicely, and then probably my best bet for another point that goes through nicely is right here. It's slightly off, but it's really close, so we'll work with that. Sometimes lines of best fit aren't the prettiest as far as giving answers. So what we're going to do here is we're going to figure out from this red point here to this red point, what's the slope? And that's just a matter of how much we're going up. So I'm going to do that in orange here. How much we're going up versus how much we're going over. And we'll do over in kind of this pink color here. So I'm going to say we're going up. Let's see, that's 3 blocks, but each block is $100. So we're going up $300. And we're going over 1, 2, 3, 4, 5 blocks, but each block is actually 2 degrees. So how much difference do we have from here to here? That's actually from 12 to 22. That's actually 10 degrees, right? So it's $300 over 10 degrees, which is really what? It's really $30 per 1 degree. That's our slope. So you can say 300 over 10 or 30 over 1. It's the same thing. Okay, and the next question is, what does the slope measure in this situation? So like what is that actually measuring here? So what it's saying is basically for every 1 degree that you go over, your sales will go up $30. So it's measuring how much sales will increase when the temperature increases. Really, we should probably say change, right? Instead of increase. So how much the sales will change when the temperature changes. Okay, so that's what the slope measures here in this scenario. Part D is saying use your line of best fit to evaluate f of 18 and explain what it means in the context of this scenario. So f of 18, literally all we're going to do is go in and find 18 for an input, right? So this is our input value. Input value is right here, and they want to know, hey, when the input value is 18, what is the output value for this? So I'm just going to come up here at 18. It looks to me like I should probably use something other than blue here. How about like a yellow color? So like that point right there, the y value there is f of 18. So what is that? A little short of 400, so maybe about $390 maybe $380. Okay, next question. Using your line of best fit and your understanding of slope, predict the amount of sales if the outside temperature was 30 degrees Celsius. So what we're going to do here is we're going to come over 30 degrees Celsius would be, so like if you continue this line here, 30 degrees would be, this would be 28, right? And then 30 would be about right here. So really the question is just asking, hey, when we actually go up here, where would this line hit? And I think perhaps the easiest way to kind of think about this is to take the sales right here at 26, right? So like for me, it looks like the sales are, I'm just going to say about $620 at 26 degrees Celsius. Okay, and then we're going to go over 4 degrees Celsius. And the question is, how much are we going to go up? We already know that answer, right? Every degree we go over, we go up $30, right? So basically, if we're going to go over 4 degrees, right, so $30 is for 1 degree. How much would it be for 4 degrees? Well, you could just multiply 30 by 4, you get $120. So I would say if you took 620 and you added $120, that would give you roughly your answer here. So I'm not saying your answer has to be exactly 740, but it should be pretty close to that. Like your answer should be between $700 and $800. If it's way more than 800 or way less than 700, it's probably not right. How much of a difference in sales would result in a 3-degree decrease in temperature? So we know that right now it's $30 for 1 degree change. So if you go down 3 degrees Celsius, what would this number be up here? So if you go down 3, what should be up here? Well, I would say, how'd you get from 1 to -3? You had to multiply by -3. So if you take 30 and you multiply by -3, you're looking at -$90. Okay? So you would lose $90. Again, you don't have to have exactly $90, but you should be pretty close to that. Most of you are probably somewhere between $80 to $120 there, depending on what you got for your slope back in the first part. All right, best of luck.